Hello everyone. So welcome to my YouTube channel. So in today's session, we are going to learn something about the type of loads acting on a building. So here we have classified the type of load into two parts, that is vertical load and lateral load. Vertical loads are again categorized into two parts, that is dead load and live load. Lateral loads are classified into two parts, that is wind load and earthquake load. Okay, so basically the vertical loads are nothing but the gravitational loads which are acting on the building. That's why they are, you can say, the gravity loads. In another word, we can call it as a gravity loads because they are acting in vertically downward direction. Because as we know that in any kind of frame structure, your structural uh, force distribution or load distribution will be in the vertical scenario. So whatever the loads are acting on any building, those are distributed from slab to beam, beam to column, column to footing in that scenario. So first of all, let me talk something about the dead load. So basically dead load, we have to calculate it by multiplying volume of any structural component multiplied by the density of material which we have used to create that particular component. Let us assume we are considering something about the beam. Okay, so beam is a structural component in which we need to consider the volume of beam multiplied by the density of concrete. Now we know that the density of concrete given in the IS code is 25. If we are going to calculate dead load of the wall, so in that case we have to consider dead load for the wall as volume of that particular wall multiplied by the density of brick if we are using material brick. Okay, so in this way we are going to calculate the dead load acting on any kind of building. The same way, unit weight of some important materials is given in IS 875-1987 part 1. So you can refer IS 875-1987 part 1, in which table 1 is for the unit weight of materials, that is unit weight of important materials, like you can say brick, wood or concrete, sand, aggregate, cement, and many more. So the next is live load. Live load is nothing but a variable kind of load acting on the building. Variable in the sense of we people usually move from one place to another inside our house. So that's why this is nothing but a live load we can consider. Furniture, weight of furniture we can also consider in the case of live load. So there are many kind of things acting on the building in case of live load. So normally live load we can consider from IS 875-1987 part 2. So there are some criteria based upon which IS has given us the live load. So live load, we have to consider 2 to 4 kilonewton per meter square according to the use of building. Like if it is a commercial building, the load will be quantity of load can be increased. If it is a public building, quantity of load can be decreased. That's how we have to consider the kind of live load or amount of live load acting on that particular building. Now these are the dead load and live load. In my coming session, we will also learn how to calculate these all four kind of loads. That is dead load calculation, live load calculation, wind load calculation, and earthquake calculation. Okay, so these are some brief concepts which we need to discuss in very detailed manner. Now the second is lateral loads. Lateral loads are nothing but which are acting on the building to displace that building, or you can say, suppose we are considering wind load. So wind load is acting on the building in a lateral manner or in a horizontal manner on the building externally, only externally. Okay. So if that building or on that building, if wind load is acting externally, how much should be the quantity of wind load? That depends upon your structure, which is located in which city. Like if you are located in Nagpur, your wind speed can be a different one. If you are located in some other cities, your wind speed can be a different one. Like you can take an example of Vishakhapatnam, which is having a more wind speed. In that case, you have to consider a wind speed much more, and you need not have to consider the amount because it is already specified in IS 875 1987 part 3. As per I have elaborated here, that IS 875 1987 part 3 will give you a descriptive manner, you can say all the things. Okay, so in that case you can see all the things, or you can say all the parameters in a detailed manner. Okay, for the wind load. Now let us something discuss about the earthquake load. So earthquake load is a kind of load acting on the building in the form of waves. Okay, so seismic waves we can call it as. So on the bottom or in your typical building, the earthquake waves will be acting in the ground. Okay, in the ground your waves will be acting, and your waves can either go in the x direction or it will be in the z direction. Okay, so that's how we can consider all these kind of loads. In my next video we are going to learn definitely these kind of loads, how we can calculate in a detailed manner if they are acting on any kind of building. So thank you. Please like and subscribe my channel. Thank you guys.